Hello student, how are you? We have been continuing with reaction mechanism, and today's video we will discuss another mechanism, that is mechanism of acid dehydration of ethanol to yield ethene. So what is the overall equation for that? Let us see the overall equation. So formula of ethanol, CH3 CH2 OH. Now you see this reaction take place in presence of acid, protic acid like concentrated sulfuric acid, phosphoric acid. So that is what this is called acid dehydration. So in presence of acid, when we heating is required, but very important thing you will remember, my dear student, that temperature is 443 Kelvin. If you change the temperature, like suppose 413 Kelvin, you will be getting some other product. So you remember the temperature. Okay. Now see the dehydration one. So hydration means addition of water. Dehydration means removal of water. D means removal. Hydration, removal of water, dehydration. So here in this equation, what water molecule will be removed, that is from the, suppose you will have carbon number 1 and carbon number 2. From carbon number 1 this OH group will be removed, and from carbon number 2 one hydrogen will be removed, and as a whole one water molecule will be removed, and you will be getting the product ethene after removal of water molecule. So this is the overall equation of acid dehydration of ethanol to give ethene. This is ethanol and this is ethene. Alright. Now we will discuss the mechanism of this particular reaction. So what is the reaction mechanism for this? Mechanism. So what is the step 1? Step 1 is formation of protonated alcohol. So my dear student, alcohol is protonated by protic acid. Yes. So let us see the CH3 CH2 OH. Here we know 2 lone pair electrons are there. This H plus from protic acid. Now this alcohol will donate, and H plus ions will take 1 lone pair electron from alcohol, and alcohol will get protonated. See, CH3 CH2 O. H was there, now one more H will come, OH2. Now here you see one positive charge will be developed on oxygen. Why? Because there will be electron deficient. Oxygen will be electron deficient. If you count this part, you see OH2, here there are 5 electrons. Oxygen valence electrons should be 6, here are 5 electrons. If you see, just you see this part, I am showing up this exactly. O, here are 2 electrons. You see 1, 2, 3, 4, 5. That is why one positive charge is developed on oxygen. Okay. Now this is, my dear student, this is protonated alcohol, that is protonated ethyl alcohol. We also say this is a ethyl oxonium ion. Okay. Now, what is the second step? Step 2. Step 2 is formation of carbocation. Formation of carbocation. This protonated alcohol will form the carbocation. Now you see how it happens. CH3, CH2, OH2. This is protonated alcohol. Now you see this covalent bond between carbon and oxygen. This covalent bond, from this covalent bond, this shared pair of electrons will pull towards this oxygen. Oxygen will pull the shared pair of electrons towards itself. Why? Because oxygen already electronegative, highly electronegative. Moreover, one positive charge has been developed after protonation. That is the purpose of protonation. That is why this bond, this carbon-oxygen bond become weak. Alright? So this bond will break and this electron pair will pull towards oxygen. Clear? As a result, what will happen? This carbocation will form. That is ethyl carbocation. This ethyl carbocation will be formed. Now, this water will get released. Here is a water molecule. No more positive charge will be there after transferring of this shared pair of electron towards this. Okay, so this particular step, my dear student, very important is this step is slow step. Slow step, as we know, these are rate determining step, RDS. This step only will determine how fast the reaction will take place. Okay, so this is why this is called a rate determining step. Rate of the reaction take place on this particular step. And this is fast step. This is slow step. Till now it is clear. Okay. Alright. Now, next you see the third step. What is step 3? What will happen in step 3? Once again you see here, just I am showing you. Yeah. From this ethyl carbocation, from this carbon, one proton will be eliminated. Alright? From this carbon, as in the beginning of itself I say, one proton will be eliminated to give finally ethene. Now how to eliminate? Let us see. Yes. Step 3, from the, you will write elimination of proton from carbocation to give finally ethene. Okay, so you write it CH2. It's just one hydrogen separately I am showing. CH3, I have CH3. Instead of writing CH3, I am writing CH2. It's here it is CH. Just you see here this one Instead of writing CH3, I am writing CH2H. And here, as it is, CH2 plus will be there. Okay? So, CH2 plus. Now, from here you see, this shared pair, this bond will break. This covalent bond will break between carbon and hydrogen, and this shared pair of electron, bonded pair of electron will transfer here and will form the another covalent bond between carbon and carbon, because here this carbon is positively charged. So this electron will transfer here, and one double bond will form, and this hydrogen will be released as proton. Have you understood? So CH2, then this is the original bond, then new bond is this. There will be no positive charge after transfer of electrons. So it is CH2. Then this proton will be released. Okay. Then we are getting now here ethene. This proton is again regenerated. Alright. This is the step 3. Would you understand, my dear students? Once again you see quickly. This is overall equation, that is ethanol. Ethene is formed from ethanol in presence of acid when it is heated at 443 Kelvin, and water has been removed. That is why it is called dehydration, in presence of acid, so it is acid dehydration. Alright. Next, mechanism. Step 1 is what? Formation of protonated alcohol. Alcohol is being protonated. Alcohol is a weak base. It is protonated to give the protonated alcohol. Then step 2, formation of carbocation. From the protonated alcohol, water is being released. Then we are getting the carbocation, that is ethyl carbocation, which is slow step. Then final step is elimination of proton from carbocation to give ethene, and proton is being regenerated. Okay, my dear student, have you understood? Is it clear? Okay, then thank you.